Okay, with that, let's switch to English, because up until now we have worked in Microsoft Azure and I have not recorded this part because this part contains a lot of student information, personally identifiable informations and so on, and I don't want to make that public. For those of you who are watching, in the next exercise, we are going to implement continuous integration for an ASP.NET Core 5 application. Continuous integration means that we are going to use a build server to build and compile our application. And then we are going also to run some unit tests. We are not focusing on C# here. So the focus is on the continuous integration and deployment part. Deployment means the third step after building and testing is that we take our application and we deploy it automatically to Azure. So if you want to follow along the third step, you definitely need an Azure subscription. Our students, you all have access to a playground, to a free playground with $100 free benefits in Azure. We have activated that together today. For those students who are absent today, please talk to your colleague, to your fellow students. They will describe and show you how you can activate your Azure benefits. External viewers, you need to get to an Azure subscription. If you are a student, you can get $100 for free. Please use Google to find the Azure student benefits. Good. Now here we have a pretty basic ASP.NET Core web application. It's just the regular auto-generated web application which shows us the weather forecast, no code written. It's not in the focus of our work today to take a look at C#, at least not now. If we have enough time later, we can talk about these things later. We want to automate the building of this application. We want to compile our application automatically using a build system. And the build system that we are going to use is called GitHub Actions. GitHub Actions is a feature from GitHub which allows you to automatically build your code into executables. What does that mean? In the context of C#, that means that your C# code is compiled into DLLs with intermediate language without you having to compile that on your local machine. If you use, for instance, C++ or Rust or Go, this will compile your source code into machine language. If you use TypeScript, maybe Angular, React, Vue, then this workflow can turn your TypeScript code into compiled and minified JavaScript code that you can then use to build your mobile app or your web app or progressive web app, whatever you want to build. And the same is true for all other languages like Python, Java, and so on. So why is continuous integration so important? Because the old saying goes, friends don't let friends publish from Visual Studio. That means if you are here in Visual Studio, yes, I showed you that you can press right click, use publish, and use the interactive UI to publish your code, for instance, in Azure. That means you compile locally, you test locally, you publish locally directly into Azure. And that is something that is meant with friends don't let friends use Visual Studio to publish applications. That is something that you shouldn't do in real world. If you're just learning and just experimenting, there is nothing bad in trying publishing that to Azure, and we have done that in the previous lesson. I didn't record that one. You can try it if you didn't follow along live in today's lesson. You can try it, but in real world, you should not do that. Why? Because multiple people work together. Maybe they have different computers. Maybe one has a Mac, one has a Windows machine, one has a Linux machine. They are configured differently, and sometimes things don't work as expected. There should be a single truth, a single source of truth for the source code. That is the source code that lives in GitHub. And there should be a single environment which is defined, which is standardized, which is always available. And this environment should do the compiling, the testing, and the publishing. If your computer works fine, everything is good. If your computer is screwed up and I don't know, you have a lot of malware installed and the malware manipulated your C# compiler and compiles malware into your application. That would be a huge security problem if you would deploy, publish directly from your computer. Therefore, we don't do that. The thing what we do is we just commit and push code to GitHub, and GitHub will provide the necessary build servers, which are free of malware, which are standardized, which are always available, and from there we publish to our cloud environment. This is the reason why we use continuous deployment. It's reliable, it's repeatable, and it's secure. Deploying from your local computer is unsecure and sometimes unreliable and sometimes not always repeatable because things tend to break. Okay? Maybe it works on one machine, but your colleague has a different setting and it doesn't work on his machine. That's a problem. If you have to deploy, you must be able to deploy. With GitHub continuous integration or any kind of continuous integration, you can always deploy because all you need to do is check in the code. This is what we want to do here. Good. Now these GitHub Actions, if I scroll down a little bit, are luckily, you see it here, very well suited for students. See that one? You get 2,000 build minutes even for private repositories. So if you build your diploma thesis or your multi-year projects and you would like to make them private because you work together with some project partners from commercial project partners, you can still use the things that I'm going to show you now. If you work on an open source project and your repository is public, don't worry about the 2,000 minutes. GitHub will donate all the necessary CPU minutes to your project for free. If you have a public repository, everything is fine. You see that one? Free. We don't have to pay anything. If you scroll here to the right, you can see that you can choose whether you want to build on Linux, Windows, or macOS. Forget the prices. They are just for more than these free minutes per month, okay? But the things that I want to point out is you get free build servers on Linux, on Windows, and on macOS. So even if you work together on a macOS application and you don't have a macOS operating system to build it, you can still build it by just checking in the code and the build will run on GitHub, for instance. Today we are going to use Linux build servers. This is what we are going to use together, okay? So this is GitHub Actions. Now what do you have to do if you want to activate GitHub Actions? The good news is nothing. It's just there. All you have to deploy is a single file. You deploy a continuous integration specification in the form of a YAML file in a very special folder, and I'm going to show you how this works, okay? So please follow along. Go into your GitHub account, and I will do that here on my machine too. So please now follow along, okay? Please create a new repository, and this repository, you can give it any name. I will call it HTL Leo Life CI CD, but you can call it whatever you like, okay? I will make it a public repository. Public repository. Create. Here you immediately see actions popping up. This is GitHub Actions. So if we go to GitHub Actions here, you will see currently nothing is installed. We could set up a very, very simple workflow which just says hello world, but this is nothing that we would like to do. We would like to set up a workflow ourselves, but don't click on this link. I will show you how to do that step by step. Nice. Please copy the link here, this one, copy it. And as usual, clone the repository on your local computer. Navigate into the empty folder which you have just cloned. To keep things simple, please copy your generated code from Visual Studio. So the code that we just together worked on. It's just a file new project. For those who couldn't follow along in the last lesson because you were absent, just go to Visual Studio and create a brand new ASP.NET Core Web API with .NET 5, okay? And that's it. That's all you have to do. We have done that together. Here it is. And I will just take this folder, cut it out here, and put it into my newly cloned folder. Yes, there would be other possibilities to directly add GitHub as a remote to an existing directory and so on, but a lot of things can go wrong. So the most easy way of doing that is clone the empty repository, copy in the code that you would like to deploy and build, and we are good. Please do not yet commit. Open this folder that you have just cloned and filled with your auto-generated Visual Studio solution in Visual Studio Code. Open it in Visual Studio Code or any other text editor. You can use another text editor too. The first thing that we always add, you know that, is a Git Ignore file. .git ignore. Now there are two possibilities. Either you go to your browser, navigate to gitignore.io, type in Visual Studio, create, and copy the code. That is one option. But today I would like to show you a different option. I'm not 100% sure if I've showed you that before. There is a super useful plugin in Visual Studio Code. Plugins, extensions can be found here. And if you look for Git Ignore, you will find this plugin here. You see 800,000 downloads with 5 stars. That's really impressive. And this is exactly the thing that you would like to install. Because what you then can do, without leaving Visual Studio Code at all, you can press F1, look for Git Ignore, you see, add Git Ignore. This is the one that we just installed. Use Visual Studio here, say yes, put it into my Git Ignore, and you're done. So this is exactly the same as going to gitignore.io and copy pasting the Git Ignore into your .gitignore file. But this is just a shortcut. We don't need to leave Visual Studio Code anymore. We can do it directly here and you will get exactly the same templates. Last but not least, please add the .vs folder into your Git Ignore because we don't want to check in the Visual Studio settings. I'm not sure if they are auto-generated here, just to make sure. Now in Visual Studio Code, please interrupt me if I'm too fast. If you have any problems or questions, please interrupt me, okay? Now here in Visual Studio Code, if we go into the integrated Git, the Git integration, sorry, we see the code, nothing special. We can add the code and we can just add a message. Add code and hit the check, use push, and the code should be up in GitHub. If you want to use any other Git client as usual, feel free to do so. If you want to use the command line with git add and git commit and git push, please do so. That's not the topic of today's lesson. Somehow you have to get your code up in GitHub with the solution and with the API project, okay? And the Git Ignore file, of course. Still, we don't have any actions. Actions are still empty here. That will be the next step, okay? I will wait for 2 or 3 minutes until everybody managed to add the Git Ignore file and push the code to GitHub. Great, then we can continue. Now we would like to add continuous integration to our project. How do we do that? Well, the first thing that I really encourage you to do is to install another plugin, another extension. You can go to the extensions and look for GitHub Actions. If you wait for a second, you will see that there are multiple implementations here for GitHub Actions. Okay, so you can install whatever you like. If you take a look here, we have one 510,000 installs here. Let me quickly look. I'm not sure if this is what I wanted to have. I have installed historically this one. Yeah, choose one. Choose whatever you like. Any of these GitHub Actions thing. I just saw that there is one which is even more popular and it has very good ratings. So you know what? I will try this one. So I will just uninstall this one. It's not bad. It's a good thing. It worked very well. But I always try new things. And today I would like to try this one. All of them are quite well. So again, this action works fine, but today I would like to run this one. Okay, good. This extension will help us. It will support us when writing a new continuous integration workflow, because we have to type in some code, and this code, of course, follows a certain syntax, and this plugin helps us with IntelliSense and documentation and things like that. Good. Let's go into the file explorer, and in order to create the GitHub action for continuous deployment, continuous integration is the first step, we are going to create a new folder. This folder is called .github. This folder belongs to GitHub. Inside of this folder, we create a subfolder which is called workflows, because we are creating a build workflow. And inside of this workflows folder, we are creating a WAML file. So a kind of JSON without curly braces. If you have never heard about WAML, you will definitely understand the file structure. It's not complicated. I will call it CI/CD.WAML. You can give it any name, but I will use CI-CD.WAML. And that is now a GitHub action specification. We have to give GitHub a kind of recipe of how to build our application, how to compile the source code into executables, in our case DLLs. Now, please follow along. The first thing that we specify is we specify the name. You see, the plugin now gives us nice IntelliSense. It says this is the name of the workflow. I will call it continuous integration and deployment. You can use any name that you like. The next thing that we are going to do is we are going to specify when this action should run. On. Inside of the on, we specify push, because we would like to run this continuous integration process whenever somebody pushes code to our repository. And then we specify branches, and here we can say main. That means whenever someone pushes code to the main branch, then we want to run our continuous integration process here. Please take a look at the documentation. Here you see the link to the documentation. Or here branches, here you see the link to various cheat sheets, or read the documentation. There are many options that you have here. You can include branches, exclude branches, you can include directories, exclude directories, you can use wildcards, and many other things more. So if you have multiple projects, for instance, front-end web application and a back-end ASP.NET Core application, you can here select that this process is only for the backend or only for the front end. There are lots of options. You can read the documentation on your own. I just want to give you an idea how this all works together, and then you can fill out the blanks and read the details in the documentations. Now let's start with our jobs. More complex projects might have multiple jobs. In our very simple example here, we have a single job because we just want to compile .NET. Give the job a name. I will call it build. The next one is now we have to specify on which platform our build should run. And that is called runs on. Here on runs on, we can select which operating system and which operating system version we would like to use. And we can use, if you type U like Ubuntu, you get the versions which are available for Ubuntu, and I'm going to be brave. I'm saying, hey, always use the latest version of Ubuntu, Ubuntu-latest. And as soon as we have specified the name of the job and the platform on which we would like to run it, we can go on and define the necessary steps. Again, there are lots of additional options which you can specify here. You can work with environment variables. You can use so-called secrets in your build, for instance, database passwords or things like that. You can, what else can you do? You can define multiple platforms, so you can build it on Windows and Linux. You can define so-called strategy matrices, and in this matrix you can define that it should run, as the name suggests, in a matrix of different configurations with different settings, for instance. Please, again, read the documentation. GitHub Actions. I want to make sure that you have the right impression. GitHub Actions is not a trivial thing. You can build really, really elaborate projects here. I want to keep it simple because this is a beginner's course, but take a look at the documentation. There are a lot of options here. Now, the steps. Which steps are available? Let's go into the browser here and just Google for GitHub Actions Marketplace. If we go here to Marketplace, and then we go here to Actions, then we see that there are impressive 7,063 different actions here that we can use inside of our project. That is pretty impressive. So there are many, many, many actions for nearly every language that you can imagine. Do you want to do something with Java? Go for Java. Do you want to do something with .NET? Go for .NET. There are so many different things here. I would like to show you some of them, and the most generic action which just says run a bash script, run a script, okay? But if you want to take a look at it, if you work in your final year projects or your 2-year projects, take a look at the actions. It is very likely that for your platform and your programming language, there are dedicated actions, and every of these actions, you can then take a look at it and read about it. For instance here, read about it, how it can be used and how you should use it, and so on and so on. I will show you the most generic ones and to give you an impression how it works. The first one, the one that we always use, is the so-called checkout action. Here, checkout, and whenever you see here verified creator, see that one? And this number of stars, you can rely on this one. It is very stable. It works very nice. And if you go down, you see that this is called actions/checkout. There is currently the version 2, which is relevant for us. And here you see the documentation of what you can do with this action. There are many, many different options. Luckily, we only need a few of them. Let me show you how we work on that. First one, give it a name, the step. Name, check out code. And of course, if you like, you can use emojis. So if you use the bell, for instance, here, like in a hotel, when you go to the clerk and you use the bell here, check out code, you can use any emojis that you like, and they will show up in the build too. So let's have a little bit of fun and add an emoji here. Then after the name, uses, and here we now use the action that we would like to use to build our code, or sorry, to check out the code. And if you can remember, it was called actions/checkout at v2. Of course, we could have copied this from here too. It's fine. And you know what the good news is? There are reasonable default values for all the different parameters which are available here. So the default values are perfectly fine. We will go for just that. Read the documentation if you need to set up details and if you need to influence the behavior of this action or all the other actions that we are going to use in details, okay? But for us, that's perfectly fine. Next, we need to make sure that our version of .NET that we are going to use is installed on the build server. These build servers are rather generic machines. They have a lot of software installed on them, but not every version of .NET is available. So we need to make sure that our version of .NET is really installed on this server. And for that, we are going to use another important action here. It is the setup.net action, this one. I somehow messed it up. GitHub Action setup.net. I am sure this one exists. I'm absolutely sure. Okay, for whatever reason, where is it on the marketplace? Why didn't I find it? Okay, maybe I should have just entered setup.net core, whatever. This is the name that we are going to use. See that one? And you see here that we can specify the version of .NET Core that we would like to use. So I am now lazy here, so I'm going to just copy this one, but I will give you a moment if you would like to type it in on your own. So let's do that one, let's do that one. Of course, we need to use a name again, setup.net 5. And what is the correct emoji? Let's use the wrench here, okay? That is okay. And here we are going to say we want to use the latest version of .NET 5 because in this code we are a little bit proud that we are always using the latest version of .NET. So of course we are going to use .NET 5. I will wait a minute so you can catch up and enter this second action. Good. So I assume that everybody has entered this part of the build process. Now we can go on and really build our application. And just to make sure that everybody is aware of how we can build our .NET application in the command line. We have covered that a few months ago. Typically Visual Studio does that for us. So let me quickly refresh your memory that you can remember how we build applications on the command line. The first step that we always need to do is a .NET restore. .NET restore fetches all the necessary NuGet packages from NuGet.org and installs them locally. What do I mean with that? Just to recap, in the CS project, you have referenced a certain SDK, and maybe you have also added some additional NuGet packages like Entity Framework and so on. And this .NET Restore fetches the SDKs and the dependencies from NuGet.org. So this is the first step that we need to do, .NET Restore. The second one is, oops, sorry, I want to go here. The second one is .NET Build. Now the .NET Build command accepts a bunch of parameters. The first parameter is -c, the configuration. We can, for instance, say that we don't want to have a debug version, we want to have a release version. And in order to make this building a little bit faster, we can tell .NET Build that it doesn't need to restore again, because we did the restore in the previous step. So this would, as you can see, build everything. Nice. Build succeeded, exactly what we wanted. Last step, we currently don't have it, but I want to make sure that you have the complete picture, is a .NET test here. See? .NET test means that we run all the unit tests. Currently, we don't have unit tests, so all we do to get warm and to get comfortable with GitHub Actions is we are going to restore and build our application. Good? So, let's do that. Name, restore dependencies. Which NuGet? This time I'm going to use that one. And here I'm not going to use any action. I'm not going to reference any specific action. Why? Because with this action up here, we have already installed .NET. So we can now absolutely rely on the fact that .NET is installed. All we need is to run a command. We can specify run here. And here we just say .NET restore. So this is the simplest way of doing a step. Just run, in this case, a shell command, a bash command, and we know that it will succeed, or it will likely succeed. But .NET, we know that it is present because we set up .NET before. This was the restore step. And last but not least, build app. Let's use the rocket icon here. Okay, run. Oops. Which one? .NET build release no restore. If you are not sure what this .NET stuff supports, of course you can get help. So just type in .NET with help and you will get all the necessary information. You see it? And for instance, if you want to know what .NET build can do, just type .NET build help and you will get all the necessary things. For instance, you will see that this -c is the configuration. This is the release version. And here you see the no restore. That means we don't need to restore NuGet packages before because we've done it already. And that's it. That's our continuous integration script. It will now build, restore and build our app. It's not super useful because, okay, it builds it, but at least we know that, that the code doesn't contain syntax errors. Don't worry, we will add unit tests, we will add deployment later on. For now, this is fine. Let's check in this CI/CD WAML. So go here, edit, add CI/CD pipeline, check, push, and let's go, oops, here to our browser window. Now, if I refresh it here, seems that nothing has changed, right? A lot of things have changed. If you go to Actions here, you will see continuous integration and something went wrong. Let me see. Maybe I have a typo here. Let's see. .github/workflows. That is correct. And here I have my WAML file. And it's here. And it looks good. Is this just me? I see now what I have done wrong. You see, this is still old settings, so it has not been switched to main branch already. And guess what? Here in the filter, I specified main branch instead of master branch. So please make sure, you know, GitHub is currently in the process of changing the defaults from master to main. That makes very much sense. You know, the discussion comes from the Black Lives Matters movement, and it makes very much sense to rename these things from master to main. But unfortunately, I haven't done that yet. I apologize for that. But yeah, here I did it, but here I didn't do it. And therefore, our continuous integration didn't run. And that's perfectly fine because we have a filter on the main branch. So let's quickly fix that. Go here into our Visual Studio Code and put a master here. Let's check that one in. Switch main to master. Fix branch filter. Yeah, that one is better. Push. Let's see. Second try. Actions. Oh, much better. You see, now we have a workflow run. So if I go here, click, Then we will see starting your workflow run. GitHub is currently looking up a server for us. GitHub has found a server for us. And you see, checkout code already worked. It's now installing on the fly .NET 5 on the build server. It did the restore pretty quickly, it did the build pretty quickly, and we are done. So if I click on it, you see 0 warnings, 0 errors. That's exactly what I wanted to have. And we have a green check. So the build process worked perfectly fine. So now I will wait for another few minutes to make sure that everybody could successfully write the YAML file, check it in, and see that the action really built the application. Before maybe we can take a short break, because we now worked for an hour approximately again after the break, and therefore we'll do a short break and everybody can use the break to catch up if you are still lagging a little bit behind. But what should you take away from this hour here? It's very simple to start GitHub Actions, which is the continuous integration platform of GitHub. All you need to do is you need to add a file to the folder .github workflows, and here you specify the steps that must be taken in order to run the build and test and so on. So this is what I wanted to show you here. And then you can use the UI in the web portal to check your builds and check whether everything is fine, okay? These are the most basic steps. Let me check the clock here. It's 10:15. We are going to continue at 10:30, and then we are going to add some unit tests and see how we can add unit tests. And last step, before we dive into more C#, we are going to deploy everything in Azure to automate the deployment from checking in until cloud computing, okay? So 15 minutes break. And please make sure that your build runs. I will quickly fetch another cup of coffee, then I will be right back on my chair here, and feel free to ask questions. 10:30, we will continue. See you in a few minutes.